Hello, this is teacher Ignace again, mathematics teacher. Today I'll be taking you through the IGCSE probability questions. So be with me and make sure we end this lesson when you understood. Okay? Feel free to chat with me. Okay? All right, so let's go through the questions. Question number 1 says, Simon has 2 boxes of cards. In one box, each card has one shape drawn on it, that is either a triangle or a square. In the other box, each card is colored either red or blue. Simon picks a card from each box at random. The probability of picking a triangle is T, and the probability of picking a red card is R. Complete the table for the cards that Simon picks, writing each probability in terms of R and T. So in this question, we shall maybe use a tree diagram. Let's draw a tree diagram as we help us to answer our questions, right? Let's draw it from here. Make sure you follow. I can draw tree diagram from here. I'll draw, let's say, this one, and then this one. This is it. The first one should be maybe a triangle. Another may be a square. And then here, you can also draw. For those squares, may have, for example, they say can be red or blue. This can be red or blue. Can be also here red or blue. Red or blue. Probability of picking a triangle. This is standing for triangle, and this is standing for square. For picking a triangle, they said it's a T, so I put T there. So I put T here. For picking triangle, I'll pick a T. And then for picking a square, since this one is T, then this will be, because the total probability of one on a blanche add up to 1. If I take the probability of here plus probability of here, they must add up to 1. That means this one here will be 1 minus T. 1 minus T. Okay? Probability of this blanche will be 1 minus T. And then here, they say the probability of picking a red card. It's R. So I put R on this blanche. I put R here. Since on this blanche, they must add up to 1. This one and this one for red and blue. Then I'll take 1 minus R from here. This is 1 minus R. And then here, it's the same case here. This is R, and this is 1 minus R. 1 minus R. Then now I can answer our questions. They said, and remember, students, remember, across the blanche, you multiply probabilities. I can say along the blanche, you multiply the probabilities. Don't add them. You multiply. If I do triangle and red, to pick a triangle and red, I multiply them. Triangle and red, it's this branch here, this one and this one. So I multiply them, TR. So the answer should be T times R. And then here, picking, for example, they said here, square and red. Square and red. You can see it's obvious, see? 1 minus T times R. It's already there in the question. They give it to us. They gave it to us. Triangle and blue. Triangle and blue. Here we have triangle and blue. It's T. That will be T. I open a bracket, then I put 1 minus R. 1 minus R. Next, they said square and blue. Square and blue. This is the square, and then blue, the last column. This one and this one. And guys, keep this one in mind. If you're going along the blanche, you multiply the probabilities because they are independent. For independence, probabilities, you multiply them. You multiply them. It's 1 minus r, 1 minus r, 1 minus r. I put my brackets. Then next step, I put 1 minus t. 1 minus t. Yeah, that's from here. Is it clear? Understandable? All right. So if you understand. Now let's go to the next point. So next question is about also a tree diagram. We have this. We have the first match and the second match. Someone is playing cricket, and want to win. The question said, win the first match. Win the first match. For winning, it's 1/3, and then for losing, you can see 2/3. Actually, if you are here to get what's missing, they must add up to 1 for each branch. Like here, this one and this one must add up to 1. Keep this one in mind. Don't forget that. If you're adding this and this column, no. So this branch and this branch, they must add up to 1. So keep it in mind. Then, for example, if I'm not given this one, what should I do? I simply take like the denominator minus numerator, and then I keep my denominator. For instance, I can take 3 minus 1, which is 2. Then I keep which was here. I keep this denominator, which was here. That will be 2/3. And then here, for example, let's say I'm given 3/4, and I don't have this. So I simply take 4 minus 3, which is 1. Then I keep my denominator. Then 1/4. The same applies to others. But here the question said at least 1 match, win 1 match. You can win the first one and the second one. You can win the first one and lose the second one. You can lose the first match and then win the second match. Those possibilities are allowed. Okay? I repeat this. You may win the first match and win the second one, as long as you are winning. Or you can win the first and lose the second. Or you can lose the first one and win the second. Then after you add them together. And when you go along the branch, you multiply probabilities. But this way is too long. Okay, let me use that way, and then after you use another one. So you can do this. You can take probability of win plus win plus win lose plus lose win. Yeah, that's what you do. Or simply you can do the one for losing, and then you take 1 minus probability for losing, you get your answer. For example, you can take 1. You can take 1 minus probability of losing, minus probability of losing, lose. Okay. What is it? It's gonna be 1 minus 2/3 times 1/4. Then you get what? You get 1 minus 2 times 1 is 2. Then 2/12. Common denominator, this is 12 here. Common denominator will be equal to 12 minus 2. 12 minus 2/12, which is 10, which is 10/12. Then you simplify by what? By 2, 5, by 2, 6. So by 2, 5, and then by 2, 6, that would be 5, over 6. The probability of winning at least one crickets, one match, is 5 over 6. 5 over 6. Then you get your 3 marks. So here we found this, but someone may find that by using the other way and they get the answer. Is it clear, this one? I think it's clear. So you try the other way, but in exam, try in the IGCSE, because time is not enough, so we need to use the shortest path, but make sure we get the right answer. Okay. The reason why I use this one, because it's the easiest one. To get at least one, I can just find the probability for losing, lose, and then I take 1 minus probability for losing, then I get my probability. All right. Let's continue to the next question. Next question says, Kat has a box of colored pens. She takes a pen at random from the box. The probability that she takes a lead pen is 0.4. Lead box. Lead pen is 0.4. Work out the probability that she does not. She does not take a lead pen. Does not. It's complement. That means probability for an event to not happen. You just take 1 minus probability of an event to happen. So I'll simply take 1 minus 0.4, and I get 0.6. So probability for 0.6 here. Okay, 0.6. So my answer should be 0.6. Maybe I should use this pen here. So I will take 1 minus 0.4, which is equal to 0.6. That's the answer for this one. Not. Okay. The box contains only blue, red, and greens. Blue, red, and green. Here the key points is this. We have the same number, 15, 15. That means they should have the same probability. That means they should have the same probability. You should guys remember this. So I may take, for example, let me call it x here. I also make this one x, the probability of blue x and probability of green x. So the total, the sum of the total or sum of probabilities must be equal to what? Must be equal to 1. This one we know it already. We apply this key. So if I take x plus 0.4 plus x, I'll get 2x. Okay, let me do step by step. I'll take x plus 0.4 plus x, and it must be equal to 1. So in this case, I'll be having 2x plus 0.4 plus 0.4, which is equal to 1. And then next, I'll be having 2x, which is equal to 1 minus 0.4, which is equal to 2x is equal to 0.6. Then over 2, I'll get my x to be 0.3. Here I got 0.3 because I divided by 2 both sides. Here, and here. I'll get 0.3. So my x's are 0.3, each one. 0.3. And then here also 0.3. All right. So now I'm having this one now is complete. I need now to complete this one here. So if I have probability, remember the sum of all probabilities must add up to 1. That one we know it. And how we find probability? To get probability, we take the favorable cases, number of favorable cases over total possible outcomes, right? So, for example, let's say I would like to find the probability of here. The probability of here, I would take 15 over 15 over the value, the total, 15 over the total of blue, red, and green. This total I don't know it. Let me call it Y, for example. This Y stands for the total of number of blue, number of red, number of green, for example, equal to 0.3 at this case. Then I may find this value. By multiplying, I'll get 0.3y is equal to 15. Then dividing both sides by 0.3, I'll get y equal to, I'll get my y equal to 15 over, I get my y equal to 15 over 0.3. What's the answer? Let me compute from my calculator here. I will be having 15 over 0.3. I'll get 50. So total number of blue pen, green pen, and red pen, 50. Then to get the number of here, I can get I'll get 50. The number of there, I'll get 50 minus 50 minus 30, because I'll take 50 minus the sum. 50 minus the sum of here and here, then I'll be 50 minus 30, which is equal to 20, right? So the answer of here is 20. Does it make sense? Okay, feel free to ask your questions, guys. Make sure you understand. At the end of this lesson, make sure you are able to do probability stuff and you don't be confused. Don't confuse yourself, right? And in the comments, maybe you can highlight what you don't get, so that next time I will bring a video which is related to that one again. Okay? In the comments, please feel free to put your comments. Very good. Number 4. Number 4 says, Dan either walks or cycles to school. The probability that he cycles to school is 1 over 3. Write down the probability that Dan walks to school. Walks to school, cycles to school 1 over 3. Remember the trick we had before? I told you guys, if you have 1 over 3, I take denominator minus numerator, and then I write my answer again. I can take 3 minus 1, which is 2, and then I keep my denominator. So simply, my answer will be 2 over 3. 2 over 3. And also, if you don't do that, you can also take like the sum of here and here must be equal to 1. If you add them together, you should get 1. Get 1. Right. And then here I have 1 over 3, 1 over 8. Then I will take 8 minus 1, which is 7, and I keep my denominator. I will take 7 over 8. Okay, next. Then here I have 3 over 8. Hi, you can guess it. You can guess and tell me what should I put that down here. I will take 8 minus 3, which is 5, and then I will write 5 over 8. 5 over 8. Very good. So now I complete my C diagram. So next point is to just answer the questions. The first question says, calculate the probability that Dan cycles to school and is late. Cycles to school and is late. It's this branch here. And remember, I told you, along the branch, you multiply probabilities. Along the branch, you multiply probabilities. You get that? So along the branch, you multiply the probabilities here. So you take what? You take 1 over 3 times 1 over 8, then that's the answer. Because they said cycles to school and then is late. So our answer should be 1 over 3 times 1 over 8. 1 over 3, 1 over 3 times 1 over 8. Then you get our answer, which is simply 1 over 24. 1 over 24. Very good. Then here, Dan is not late. It's not late. Keep this in mind. It's not late. Dan is not late. It's not late where? Can it be late when it circles? It can also be late when it cannot be late when it walks to school. So that's the case. Then we circle where it's not late. He's not late here, and also he's not late here. So how do you reach here? Circles and then late. Here, walks and then late. And you multiply. You have two options. He may be late. He may be not late when he circles. That's one option. Or he may be not late when he walks to school. Okay, that means you need to add. Remember, if it's all, we add. If it's and, we multiply them. If it's all, we add. Then if it's and, we multiply. But here, this is all because it can circles. He may circles and not late. That means we do this one. 1 over 3 times 7 over 8 plus 2 over 3 times 5 over 8. Then we get our answer. So simply our answer would be 1 over 3. 1 over 3 will be 1 over 3. 1 over 3 times 7 over 8. 7 over 8. Then plus what? The last part here. Works and then not late. That means 2 over 3 and 5 over 8. 2 over 3 and 5 over 8. 2 over 3, 2 over 3 and then 5 over 8. 5 over 8. Very good. Now we'll be having 7 over 20. 7 over 24 plus 10 over 24 as well. Then if we add them together, we shall have 17 over 24. So this is the answer. Dan is not late. Dan is not late in this scenario, this question. Clear? Okay. If it makes sense. If it makes sense, then we can proceed with number 5. Number 5, pay attention. Pay attention. This video is related to the previous lesson. Make sure you also watch the previous lesson to understand this. Okay? It's about sets, and you can see sets. We use sets. The most used sets in the probability. In sets, you need to understand sets before you do this. That's why I posted the video on sets for you guys to understand those types of probability. All right, let's move on. Here we have in each class of 30 students, in a class of 30 students, 25 study French and 18 study Spanish. One student does not study French or Spanish. One student. This is the trick. You know this one. It's not highlighted, but you should also read it and understand. In a class of 30 students, 20 students study French, 18 study Spanish. One student does not study French, all Spanish. Then this student, I put him outside. Let me put one student there outside, and is there, and they are 30. Don't forget. Then among those 29 remaining, so we are having 25 study French, 18 study Spanish. Actually, if you find the total, if you look at this, if you look at like 25 study French, and then 18 study Spanish. If you add them, you find the sum is equal to what? The sum will be equal to 25 plus 18, which is simply equal to 43. 43. And you guys, you can see the number of students are more than the one which are in the class. They're supposed to be 30. So one is outside, that means 29. So I'll take 43. So I'll take 43 minus the number which are remaining, which is 29, because one is outside. Then I'll get the one which are in the middle. So I'll take 43 minus 29. Then I'll get 14 students are here. That's 14 students. 14 students are inside here. And you guys remember, 25 study French. 25 study French. How many should be there? If there are 25 study French, then you take 25 minus 14. Okay? Minus 14, then you get what to put there. That would be 25 minus 14, which is simply 11. So 11 students study Spanish, study French, and then here 18 study Spanish. And we are having 18, then this is 14, then we can take 18 minus 14, then we get the remaining. What is it? 4 students. Now let's verify if our graph satisfy all the requirements. They say 25 study French. Let's add and see. If you take 14 plus 11, 25. They said 18 study Spanish. 14 plus 4, 18. They said 1 is outside. That will be, if you add all of them together, 14 plus 4, 11 plus 14 plus 4 plus 11. So we shall have, this is 18, 29, 30. Okay, you're right. Now answer the question. Find the number of students who study French and Spanish at the same time. French and Spanish. It's obvious, they're here. French and Spanish, there are 14 students there. And then a student who does not study Spanish. I must write this one. Who does not study Spanish? Who does not study Spanish is chosen at random. Find the probability that this student study French. A student who does not study Spanish, who does not study Spanish is where? Who does not study Spanish is where? Who does not study Spanish? So it's here. See this part. This part here to be 11 and 1. Then they said find the probability that student study French. So 11 study French. Out of how many? Out of 12. Because if I take 11 and 1, that will be 12. But they said study French. So my answer should be 11 out of 12. Okay, next. Next is here. Let's shade accordingly. On the Venn diagram, shade the region R intersection P union Q complements. Remember, in the first video, we saw complement means Yeah, outside that region. Like here, P union Q, it's outside of P union Q, right? So what we do here, I need to first highlight this one. That means outside of P union Q. Simply, in short words, we don't touch the union of P and Q. It's outside that. Let me shade the part and then we find its intersection with R. So this is the part here. P and R, we don't touch them. That means it's outside. Supposed to be, let me use this highlighter. Supposed to be this part. Use this color. Must be this part here. This part. This part. But they said its intersection with R. Let me use a different color to highlight intersection. Let me use this one here. This is the intersection with R. Only this part here. Only this part. That part. So the answer should be only this region. Should be only this region. I may lab the stuff I don't need. Like here, I only need that part. That last region I shaded. So my answer should be that part only. So this is my answer. So this is my answer. The answer is only here. That's the only answer. You find it. Intersection with R. That part intersection with R. That means we don't touch intersection of union of P and Q. Okay, good. So next, let's now move on to the next question. Next question is about also the probability. So it's now like this season of COVID-19. This is also a flu pandemic. It's an epidemic which was there. So in a flu epidemic, 45% of people have a sore throat. If a person has a sore throat, the probability of not having a flu is 0.4. And if a person does not have a sore throat, the probability of having flu is 0.2. Now, let's complete this one. Like here, 0.45. What should be this data here? I simply take 1 minus 0.45. I get this one here. So I will simply take the answer here. I'll take 1 minus 0.45. Then I get my answer, which is supposed to be 1 minus 0.45. It's 0.55. So my answer is 0.55. And then here, I will simply take 1 minus that one. 1 minus 0.4, which is 0.6. And then here, I'll take 1 minus 0.2. I get the answer here. 1 minus 0.2. Then I get 0.8 as well. Okay. Now I can answer any question like they ask me. They ask us to find the probability that a person chooses at random has a flu, has flu here, and also has flu here. That means you may have sore throat and have flu. You may have no sore throat, but also you have flu. That's what you call asymptomatic. I think so. In terms of etymology, you call it as symptomatic. So now here, let's multiply. That means we along the branch you multiply probabilities. Along the branch you multiply probabilities. Like here, I multiply. So my answer should be. Actually, you can see it's too often. It can be sore throat and flu. All should be 0 points sore throat, all and flu. So you add them together. And don't forget it. Along the branch, you multiply probabilities. Along the branch, you multiply probabilities. Then after, you add them together. Okay? Then that should be, our answer should be 0.45 plus times 0.6, then plus 0.55 times 0.2, which is equal to just 0.45. If we multiply 0.45 times 0.6, it gives 0.27, then plus 0.55 times 0.2, which is simply 0.11, 0.11. Then you add them together. So we shall have 0.11 plus 0.27, which is simply 0.38. This is the answer. Any questions so far? I hope you guys understand. Subscribe to my channel, and then you'll be getting other stuff like this. Let's continue. Next question is this one. Yeah, we have alums narrated and numbered from 1 to 19. Looms are allocated at random as guests alive. What is the probability that the first guest to alive is given alum, which is a prime number? You know a prime number? It's a number which is divisible by 1 and itself. Okay, keep it in mind. It's a number which is divisible by 1 and itself. And also, pay attention, 1 is not a prime number. 1 is not a prime number. So basically, which prime number do you have? We have 1. We have I just want to write all the prime numbers which are here, which are there. Or I may first write the list. Which numbers are there? We have 1. We have 2. We have 2. We have 3. We have 4. We have 4. We have 5. We have 6. We have 7. We have 8. We have 9. We have 10. We have 11. We have 12. We have 13. We have 14. We have 15. We have 16. We have 17. We have 18. We have 19. Yeah, that's all. Okay, because it's from the number from 1 up to 19. Then among those numbers, we are having prime numbers there. Let me use a different color. Maybe I should use this one here, or I use a lighter. And I select them. So this is a prime number, a prime number, prime number, a prime number, prime number. This is the prime as well. This is the prime, and this is the prime. So I have how many numbers? 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 prime numbers in this list out of 19 numbers. Basically, the probability of having the first guest to alive is alive to be a prime number. To get a room with a prime number, I'll take 8 over. I'll get 8 over 19. That's the probability. Then the second guest. The first guest to alive is given a room, which is a prime number. That means a guest is there. Now it has a room, and the room is a prime number. So how many prime numbers do we remain with? Remember, there were 8. There were 8 rooms with prime numbers, and one room is already occupied with a guest. Then the second guest, what should be the probability for the second guest to get the prime number? Okay, so actually it will be, because this is dependence. So it will be 8 over 19 times, because we still have 7. One is already, this one is already fixed. Then for the second one, it will be 7 out of 18. One room will be occupied. There will no longer be 19. There will be 18. Then that's how we find it. So in this case, we shall have 8 times 7, which is simply 56, over 19 times 18. 19 times 18, which is simply 342. 342. Then you simplify. I can simplify by 2. By 2, I'll get. I get what? I get 56 by 2. I get 28. What about by 4? By 4, will it work? If you take 56 by 4, I get 14. Okay, 342 by 4. I'll get. Oh, that is what? That is small. Okay, let's do it by 2. By 2, that would be 20 watts. By 2, it's 28. Then by 2 there, it's 342. By 2, it's 171 over 171. That's the answer. That's the probability we are looking for. And that's it, you guys. Before you leave, make sure you subscribe to my channel also, so that you may get other lessons from me. Thank you very much. May God bless you. May God bless you. And make sure you revise very well. Have a nice day. Thank you. Bye-bye. Ciao.